In this video, we'll take a deep dive into using Terraform to manage Spectro Cloud resources. We'll start with a short intro on Terraform and the value of infrastructure as code, followed by a demo on provisioning a VMware cluster using the Spectro Cloud Terraform Provider. With the rise of a DevOps culture, enterprises are increasingly relying on automation to manage their infrastructure. Specifically with infrastructure as code tools, enterprises enjoy a number of benefits compared to manually managing their infrastructure. The first one being cost reduction. By removing the manual work, teams are now able to focus their efforts on other value-adding tasks. Also, with automation, you gain a faster time to market, as teams across enterprises now work more quickly and efficiently. And of course, reducing the risk of human error, like manual misconfiguration, which may lead to downtime and outages. One of the more popular infrastructure as code tools is HashiCorp Terraform. What sets Terraform apart from other DevOps tools is that its declarative approach to management. In Terraform, you describe the high-level plan of what the desired state should be, as opposed to describing the details on how to do things. Kubernetes is also built on the same fundamentals, as is the Spectro Cloud platform. Now, Terraform manages external resources such as cloud infrastructure, both PaaS and SaaS services, and essentially any resource which has a CRUD-like API backend. Common examples of resources managed on the cloud include virtual machines, load balancers, security groups, and so on. For each external resource, Terraform has a pluggable architecture of providers which it uses to manage the resources. Okay, let's jump over to the demo. Let's take a look at the Terraform provider Spectro Cloud publishes. Navigate to the Terraform registry at registry.terraform.io and search for Spectro Cloud. From the provider main details page, click on the documentation link. The provider documentation has basic details on how to install and configure the provider, along with the resources that it manages. Select the resources section, and the primary resources that this provider manages are the cloud accounts, clusters, and cluster profiles. From here, we can jump to an end-to-end example. Scroll in the documentation until you get to the end-to-end examples. If you're using VMware, select vSphere. Otherwise, choose your cloud of choice. The README has detailed instructions on how to configure the provider. We'll switch to our terminal where we have a clone of this repository. In the terminal, go ahead and switch directories to your cloned repository. From here, go into the examples E2E directory and pick your cloud provider. Take a look at the README file. And also, there is a template, terraform.template TFVars files. Go ahead and make a copy of that and call it terraform.tfvars. Edit the file and specify all the missing values. After specifying the designated values, let's go ahead and take a look at the resources to be created and take a look at the resource cluster profile. In this configuration, we're going to be creating a new cluster profile that has a name vSphere Picard 2 and the cloud type is vSphere. It's composed of a number of different packs like the Ubuntu operating system, Kubernetes at version 1.18.15, Calico, volume driver, and also a bring your own manifest. If we take a look at the resource cluster, the cluster to be created is a vSphere cluster, which will have a name of vSphere Picard 2, and the cluster profile ID will be based on the cluster profile that we just created, as is the cloud account. There's a number of cloud configuration parameters that are coming from the configuration file, such as the vSphere data center, the folder selection, and so on. If we scroll down a page, you'll notice that there are two machine pools. There is a master machine pool, as well as a worker machine pool. We can go ahead and add an additional worker machine pool, and we'll call this one worker advanced and specify count as 1. We'll leave the same placement properties and the same instance configuration. All right, let's go ahead and save the file, and then we can run Terraform plan. This will show us that 3 resources are being created. And let's go ahead and run a Terraform apply. And to the prompt, type in yes. And from here, switch to the UI console. So let's go ahead and take a look. If you switch to the cluster profiles page and scroll down, you'll see a new vSphere Picard 2 cluster profile that is based on the Ubuntu and Kubernetes networking storage and the bring your own manifest that we created in the cluster profile. If you switch over to the clusters view and scroll down, there is a new vSphere Picard 2 cluster that is currently provisioning and creating the first new control plane node. Switch to the nodes tab, and you'll notice the three machine pools: the master pool, the worker advanced, and the worker basic. Let's go back to the overview tab and wait for this cluster to finish provisioning. And now the vSphere Picard 2 cluster is fully running in a healthy state. The metrics of the CPU and memory are also being reported back, along with any application services and other configuration. Let's go ahead and switch back to the terminal. You'll notice that the Terraform provider successfully finished, saying that the resources have been completely created, and along with the kubeconfig that is exported out. If you go ahead and list out all the files in the vSphere directory, you'll notice that the kubeconfig vSphere 2 is also available as a file to export. Let's go ahead and export this kubeconfig and run a command like kubectl get pods. And there you have it. The cluster is fully up and running.